Okay, let's go ahead and work this this example, this flow rate example. And in this question, we have a certain flow rate, and we are asked to calculate the velocity in both the hose and the nozzle in this problem. So, so the flow rate then is 0.5 liters per second. Okay, now we need that in cubic meters per second. We need it in standard SI unit now. So there are 10 to the minus 3 cubic meters in 1 liter. Okay, so that's a minus sign up there. Okay, so you multiply that here and you get 5 times 10 to the minus 4 cubic meters per second is our flow rate. Okay, so that's our flow rate then. Now, if we want to know what the velocities are in the hose and the nozzle, we have to relate the flow rate to the velocity. And flow rate is related to area, cross-sectional area of a tube, and velocity by this expression. Now, if this is a circular tube, like a hose or a nozzle, the area of something that's circular is pi times the radius of that tube squared. That's the area, and then times velocity. So if we want to know what the velocity then of the hose is then, okay, it's the flow rate divided by pi radius of the hose squared. Okay, so we plug this stuff in here. We have 5 times 10 to the minus 4 cubic meters per second is our flow rate. Because remember, the flow rate is the same everywhere in the fluid flow, whether we're talking about the hose or the nozzle. Okay, divided by pi, and the radius of the hose is 0.9 centimeters. So we need to get that into meters. So 0.9 centimeters is 0.009 meters. Okay, and don't forget the squared here. So when you do that calculation, you get the number 1.96 meters per second. That's the hose velocity. Now, if we want to know what the nozzle velocity is, well, the nozzle velocity is going to be the flow rate divided by pi radius of the nozzle squared, just as it was for the hose. The flow rate is the same in the nozzle, 5 times 10 to the minus 4, divided by pi, divided by the nozzle radius squared. The nozzle radius is 0.25 centimeters. So in terms of meters, that's 0.0025 meters. And don't forget squared here. So you do this calculation, you get a considerably larger result. It's 25.5 meters per second. Okay, so as expected, we have a much higher velocity in the hose than we do in the nozzle.